Welcome. This presentation explored the integration of the surface dissolution imaging with explainable artificial intelligence to model the drug release process from oral solid dosage form. So as we know that drug dissolution is a critical parameter in the development of the oral solid dosage form, it directly influences the viability and the therapeutic efficacy. However, traditional dissolution testing is essential for the quality control, but it's offer limited insight into the dynamic events that occurred during the dissolution process, such as the gel forming layer or erosion. Recent advancement in the machine learning and artificial intelligence have opened new possibilities in the pharmaceutical science. These technologies enable deeper analysis and understanding of complex processes, including the drug dissolution. So in this study, it leverages these tools to enhance the understanding and the prediction of the drug release behavior. The primary objective of this study was to explore the dissolution and process of tablets using machine learning techniques supported by a real-time surface dissolution imaging. The approach was comprehensive, encompassing formulation development, dissolution testing, image processing, and predictive model construction. So we had a tablet that we prepared using direct compression. And the chosen APIs were include acetylsalicylic acid, sodium salicylate, and salicylic amide. And two excipients were used, lactose, highly soluble filler, and methylcellulose gel-forming polymer. And the calibration curve were constructed in both acidic and neutral pH media. And dissolution testing were performed using the SDI2 machine, which capture a dual wavelength real-time imaging data. So we had the 280 nanometer for API visualization and 520 nanometer for the structural changes. Dissolution videos were processed using Python and OpenCV to extract frame. And these frames or image were analyzed using Fiji and SurfChart-J to calculate the surface texture parameters. And the data were input into RKinet DS and Orange 3 software for modeling. Also, various machine learning models were developed, including linear regression, random forest, and convolutional neural network. Here is the result taken from the SDI2 instrument of the placebo lactose tablet at pH 1.2, which is like on the left side. On the right side, we have the sodium salicylate lactose, both at the same wavelength. So we can see from this video, from this wavelength, so we can demonstrate the structural changes. And it's also give us the dissolution process shows a distinct behavior depending on the formulation. Here's another example. So similarly, we observed the acetylsalicylic acid methylcellulose tablet at pH 6.8, which like in this wavelength, it's provide more data on how the API is being released into the chamber. Here's the tablet of my results that I got from this study. So like as we see, like model performance varied across techniques. So we have the H2O tool. It's achieved the highest accuracy with the lowest RMSE. Also, one more model that is important, which was the convolutional neural network, which later on the next slide I will talk more about it. But with this model, I achieved 0.89 R square with the RMSE of 11.57. So, in general, like these results demonstrate a potential of these models in learning and predicting the solution profile with high accuracy. Yeah. So, also I need to talk about the GRAC-CAM, which is like this amazing tool. So like the GRAC-CAM analysis provided a visual insight into the convolutional neural network decision-making process. So like as we can see at figure C at 280 nanometer, the model is focused on the surrounding medium, indicating the sensitivity to the API concentration. And at figure D, at 520 nanometer, attention was directed toward the tablet's structure, capturing the erosion and swelling dynamics. And so these focus area correlated with a known dissolution mechanism, confirming that the model is learning meaningful features. This support the model reliability and demonstrate the potential of the explainable artificial intelligence in pharmaceutical research. To sum up, this study shows the ability of the use of the SDI2 integrated with artificial intelligence to predict the dissolution profile. Also, a convolutional neural network was able to learn and highlight the dissolution relevant features. And formulation composition was shown that is significantly influenced the release kinetics. And looking ahead, the dataset can be expanded with additional formulation and imaging condition. Also, the framework may be applied to other dosage form or drug delivery system. Thank you for your listening.